Welcome to Brain Vision.
Okay, so here we're given that theta, the equation for theta in terms of t, would be equal to 8.5t minus 15.0 plus 1.6 t to the fourth power. For part A, when we want to find the angular velocity in terms of t, this would simply be equal to the derivative of the angular displacement in terms of t with respect to t. And this would be equal to 8.5 minus 30.0 t plus 6.4 t cubed. For part B, when we want to find the angular acceleration in terms of t, this would simply be equal to the derivative of the angular velocity in terms of t with respect to time, t. This would be equal to negative 30.0 and then plus 19.2 t squared. The units for the angular velocity would, of course, be in radians per second, and for the angular acceleration would be radians per second squared. For part C, when they want us to find the angular velocity at 3.0 seconds, this would simply be plugging in 3.0 seconds for t. So this would be 8.5 minus 30.0 times 3.0 seconds plus 6.4 times 3.0 seconds quantity cubed. This would be equal to approximately 91 radians per second. For the angular acceleration at 3.0 seconds, this would be equal to negative 30.0 plus 19.2 times 3.0 seconds quantity squared. This would be equal to 140 radians per second squared. At this point, we can say that for part D, let's get a new workbook. For part D, they want us to find the average angular velocity between 2 seconds and 3 seconds. So we can say that the average angular velocity would be equal to the delta theta, so the change in angular displacement with respect to time. This would be equal to theta at 3.0 seconds minus theta at 2.0 seconds divided by 3.0 seconds minus 2.0 seconds. So we can say that omega average, the average angular velocity, would be 8.5 times 3.0 seconds minus 15.0 times 3.0 seconds quantity squared plus 1.6 times 3.0 seconds quantity to the fourth power, close parentheses, minus, and then we'll just put it on a new line, 8.5 times 2.0 seconds minus 15.0 times 2.0 seconds quantity squared plus 1.6 times 2.0 seconds quantity to the fourth, close parentheses, and this would be divided by 1 second. And we find an average angular velocity of approximately 38 radians per second. So this would be your answer for part D. And then for part E, they want us to do the exact same thing, however, with the angular acceleration. So for E, we have that the average angular acceleration would be equal to the change in angular velocity with respect to time. So this would be equal to the angular velocity at 3.0 seconds minus the angular velocity at 2.0 seconds. And this would be divided by, again, 3.0 seconds minus 2.0 seconds. We can solve. this would be 8.5 minus 30.0 times 3.0 plus 6.4 times 3.0 quantity cubed, close parentheses, minus 8.5 minus 30.0 times 2.0 plus 6.4 times 2.0 seconds quantity cubed. Close parentheses, all divided by 3 minus 2, 1.0 seconds. And the average angular acceleration would then equal approximately 92 radians per second squared. So this would be your answer for part E. That is the end of the solution. Thank you for watching.